Assalamualaikum and hi, my name is Muhammad Fakrul Adam bin Muhammad Zahir and my matric number is 01 DKM24F1023.
Assalamualaikum. My name is Khairul Amirin bin Zulkhairi and my matrix number is 01DKM24F1037.
Our group will present about the renewable energy adoption in Malaysian industries. So renewable energy refers to energy source that can be naturally replenished, such as a solar, wind, hydro, and biomass. In Malaysia, the use of renewable energy is increasing as a country aims to reduce dependence on fossil fuels and support a low carbon economy. Many industries are now adopting renewable energy system to power their operation. For example, solar panels are used in manufacturing plants, while biomass energy from palm oil waste is used to generate electricity. So why is this important? It is very important to help reduce greenhouse gas emission and combat climate change. Second, lowers energy costs for industries in for the long run. And then lastly, the reason is very important is encourage innovation and promote sustainable industrial growth. So this is the current energy situation in Malaysia. Malaysia still relies heavily on non-renewable energy source, mainly coal and oil to generate electricity. Currently, around 80 to 85% of Malaysian electricity comes from these fossil fuels, while renewable energy contribute only 20% of total generation. Many industries, especially in manufacturing and agriculture, are beginning to install solar panels. For example, Top Glove and Samdabri have installed solar system to reduce electricity consumption.
This is the challenges in adopting renewable energy in industries. So first, high initial investment cost. Capital intensive setup. Installing solar panels, wind turbines or biomass plants requires substantial upfront investment. Long payback periods, although operational costs are lower. The time to recover the investment can be long, which discourage many firms, especially small and medium enterprise. Second challenges is energy storage and reliability issues. Intermittent supply, solar and wind energy are dependent on weather conditions and time of day, causing fluc- fluctuations in power availability. Insufficient storage technology, industrial operations require continuous energy supply. Current battery technologies are expensive and have limited capacity for large-scale use. So the third challenges in adopting renewable energy in industries is third, infrastructure in grid and grid limitations. Grid compatibility. Many existing grids were designed for centralized fossil fuel systems and are not optimized for distribute renewable inputs. Transmission challenge. Renewable energy sites such as wind farms are often far from industrial centers, leading to high transmission costs and energy loss. Lack of smart grid system. The absence of intelligent grid management hinders efficient integration of renewables. So fourth challenges is technological and operational barriers. Retrofitting existing systems. Many industrial plants are designed for fossil fuel use, making integration of renewable technically complex. Process heat challenge. Some industries like cement, steel, chemical require very high temperatures that renewables currently struggle to provide economically. Technology gaps, lack of mature technologies for certain renewable applications such as hydrogen-based heating and bioenergy gasification. And here are some reasons for using renewable energy in industries. So first reason is environmental sustainability. reduction in greenhouse gas emissions. Renewable energy like solar, wind, hydro, biomass produce little to no carbon emissions compared to fossil fuels. Lower air and water pollution. Cleaner energy source reduce particulate emissions. Acid rain and water contamination from industrial process. So second reason is cost savings in the long run. Decreasing technology costs, price of solar panels, wind turbines and energy storage system have dropped significantly over the past decade. Lower operational and maintenance costs. Once installed, renewables have minimal fuel and maintenance expenses compared to the conventional system.
Next, the effect of renewable energy adoption in Malaysia industry. First, environmental benefits. It reduces greenhouse gas emission and air pollution. And then it helps slow down climate change and protect natural ecosystem. And then, for example, solar energy reduce reliance on coal and natural gas. Next, economic benefits. It lower long-term energy costs for industry. It creates new job opportunity in green technology and renewable energy sector. And then, for example, Nestle and Top Glove saves million in operational costs after switching to renewable energy. For the social benefit, it improves community health due to cleaner air and less industrial smoke. It raises awareness about environmental protection and sustainable practice. Enhance quality of life for surrounding communities with cleaner surrounding. And then, for examples, solar adoption in industrial parks reduce air pollution benefits renewable residents. And then lastly, for industrial and technologies benefit, encourage innovation in energy efficient system and smart technologies. And then, for example, for support digital transformation through integration with smart grids and IoT monitoring. And then lastly, for example, Sam Darby used smart energy system to track and optimize solar power use.
Selamat sejahtera Encik Khairulism. My name is Nisha Anak Laki Peterpal. My matrix number is 01 DKM24F1036. I am from class DKM3A. And now it is my turn to present the engineering principle for renewable energy adaptation. I will be presenting these few slides, and first let's talk about the few engineering principles for renewable energy adaptation. The first one is system integration, and then we have thermodynamics, material science and process optimization, and followed up with control closed system, power transmission and power electronics. And the final one is grid stability design. Next, I'm going to be talking about the three main engineering principles that are used for renewable energy adoption. The first one is systems integration. Effective renewable energy adoption relies on seamless system integration, where diverse energy resources, storage units and demand side technologies operate cohesively within a unified framework. Integration ensures the coordination operation of generation, transmission and consumption systems, enabling flexibility and resilience. Through smart grids, digital monitoring, and hybrid configurations, system integration enhances the utilization of variable renewables and stabilizes supply-demand dynamics. And it also supports the transition toward a decarbonized energy ecosystem. For the next principle, I'll be talking about thermodynamics. For thermodynamics, the adoption of renewable energy is fundamentally guided by the thermodynamic principles that emphasize the energy conversion, efficiency and entropy management. The renewable systems such as solar, wind and geothermal energy, these harness natural energy that flows with minimal entropy generation compared to fossil fuels, however. By optimizing energy transformations through advanced materials, heat recovery and storage technologies, thermodynamic efficiency can be maximized, reducing energy losses and enhancing the overall sustainability of energy systems. And for the final engineering principle, I'll be talking about grid stability design. With grid stability design in renewable energy, the adoption focuses on maintaining voltage, frequency and power quality amidst fluctuating renewable generation. As solar and wind sources are inherently intermittent, stability is achieved through advanced control systems, real-time monitoring, and energy storage solutions, such as batteries, flywheels, and incorporating inertia emulation. Demand response and adaptive grid management strategies ensures that renewable-based power systems remain reliable, secure, and capable of sustaining continuous and balanced energy delivery. For the next topic I'm going to be explaining, this topic is about engineering innovation and green technology for renewable energy adoption. For the first one, I'm going to be talking about solar photovoltaic rooftops. The installation of these rooftops, which can help reduce reliance in electricity because it generates its own clean electricity. The next one is battery energy storage systems, also known as BESS. For example, like lithium-ion or flow batteries that can help ensure reliable power supplies for 24/7 industrial operations. And the final one I'm going to be talking about is smart grids and advanced metering infrastructures that allow national grid to better integrate and manage high penetration of distributed renewable energy sources.
Assalamualaikum and good afternoon to Sir K. Rizam, my lecturer for Engineering Society. Today I, Luqman Hakim bin Yusuf, number metric 01 DKM34F 1032 from class DKM3A, will be explaining about related findings on national or global frameworks regarding the renewable energy adoption for Malaysia industry. Number 1, the Malaysia Green Technology Master Plan GTM-PG 2017 until 2030 will focus on the energy sector. The GTMB specifically aims to increase the share of renewable energy in the power mix and drive energy efficiency practices across all sectors, including manufacturing and industry. Second of all, green business and economy. The GTMP will also plan to seek to spawn new economic opportunities in green technology. Number 2, the Sustainable Development Goals (SDGs). SDG 7, affordable and clean energy, is to double the global rate of improvement in energy efficiency. SDG 13, climate action, will reduce the greenhouse gas emission from the industrial sector in Malaysia and enormous consumption of energy. SDG 12, responsible consumption and production, focuses on sustainable management of energy, uses of natural resources and utilizing industrial waste for biogas generation, links waste management to energy production, fulfilling the goals towards a better world. Next, I will proceed to number 3, National Energy Transition Roadmap, NETR. Its goal is to reaffirming the ambitious target to achieve 70% renewable energy installed capacity in the power mix by 2050 in Malaysia. Initiatives outlines flagship catalyst project and impact initiative across energy transition levels, including renewable energy, and aims to accelerate utility scale and other forms of solar development. Number 4, the last one, the Malaysia Renewable Energy Roadmap, MyRER. Its goal is a strategic framework to support the decarbonisation of electricity sector. It targets achieve 31% of renewable energy share in national installed capacity mix by 2025 and 40% by 2035. Its strategy includes the technology-specific pillars: solar, bioenergy, hydro, new solutions, and key important things like the enhancement of the existing net energy metering program to promote rooftop development and deployment, which is critical for industrial and commercial sectors in Malaysia industry. Next, I will forward onto the last one, which is the conclusion. Next, let's go to the last one, which is the conclusion of this slide. The transition to renewable energy within the Malaysia industrial sector is not merely an environment option, but a critical economic imperative driven by the national policy and global demand. While the country possesses significant untapped solar and hydro resources and supportive frameworks like National Energy Transition Roadmap and net energy metering, widespread adoption is currently hindered by infrastructure constraints and a dependency on fossil fuel. Moving forward, success requires integrated action, for example, accelerated investment in grid flexibility such as BESS and smart grids, and to make decentralized solar and bioenergy solutions the clear cost competitive choice for industries aiming for energy security and international decarbonization compliance within the Malaysia industry.